Good morning, Allplan users. It's good to be back on Allplan Day. This year, Quadrant is back and we are going to show you what we have been doing on the last year. Of course, we have been doing bridges, viaducts, modeling, using Allplan Engineering, Allplan Bridge, and all that package. Of course, that we finished Ruby Line in Método do Porto, that is starting to be constructed on the field. The Nigeria project is going on forward, and we also made the development of bridges, viaducts, and overpasses on a railway line in Portugal between Casabranca and Beja. But that's not what we would like to talk about this year, because there is nothing new on that, and we would like to share with you our developments in the Python area overall plan. So our strategy for Python part development is based on two main axes. One axis is focused on the PYP file, the XML file for the interface, and the other axis is for the PY file. In terms of PYP file, the XML interface, we produced a tool in Excel where with the VBA language behind that allows us to configure the different commands and tools that are present in the interface, and the program automatically writes the XML code. This allows us for persons with little knowledge of programming, only VB programming knowledge, to be able to define an interface for a Python part. The other axis is focused on the PY file, the Python file code, and there the difference from our approach is that we are trying to condense the aspects of the coding that is purely Python and related to the interface between Python and Allplan to specific functions. So we are creating new functions that can include two lines of code or 10 lines of code. But at the end, the programmer, the user, only calls those functions. Okay, with that we have a specific list of parameters, and so the main code is simpler, is something more used to what do you use on our day-to-day basis, and so more people can design, create Python parts in a more easily way, and so that will speed up our production and more efficiently. This is our Allplan Python Interface Manager. It's intended to produce the interfaces, helping the user to customize the interfaces. Mainly for one interface, you have to have two sheets. Here, for example, is a configuration sheet where for different types of controls, we have the instructions that are required, which type of data, and also some information comes from this sheet, where the configuration of each control, the requirements for its definition are established. Of course, the information in these two sheets are only for administrator configuration, use, changing. A normal user just works on these two sheets. So after this explanation, I'm going to create a simple interface with two pages, a text box in one and an integer slider in the other page. So I have to go to text one, to this page. I choose the type of control. First one is a page. Automatically it fills on the parameters that are required or optional for this type of control. The orange are the required, the greens are the optional ones. So I fill it, I call it page P1, for example, and the caption will be page 1. Then I'll choose the text box as said. So control will be T1, the caption text 1. the program is showing me that I also have to fill in this field, okay, the value type, integer, let's choose it, okay. If I had made a mistake and they had put something 2 hours in the end, it will show me, it will stay red because it does not check with the data, the possible values that are indicated above. So I take it out, goes not red. So I go to page 2, okay, let's just go P2, let's name it, or name the text page 2. Then I go to integer slider, it's E1, let's call it slider 1. I'll choose to give 10 and 100 here in terms of maximum and minimum value, and that's it, okay. So this is where I define the different controls, but then I have to define the order of the controls. It may not be this one, okay. So I go this side. Now I say that I have to create or put controls inside the interface, okay. So page 1, of course this is some sequence and I have to respect what's on the labels of the columns. This is page 2, and this one is I call it, sorry, E1. Okay, it's done. Previously to all this, I have defined the PYP file name and folder here, and also I have defined the PY file that is going to connect to. It's PY minimal equivalent in English. It doesn't do anything, but it works. Okay, and also I had to show that information for this sheet comes from test2, this sheet here. So I click write code. It ended, terminado, concluded in English. If I go to the whole plan, let's go inside the folder where it is, contents, and I see test2 1. Okay, let's press it, and I have 2 pages, page 1, page 2. The first one, there's a text box. The second one, there is a slider that goes from 10 to 100. Okay, this is how it works. Of course, it can do more complicated things and verify some connections between the different controls, for example, in terms of Boolean operations. Okay. It tells us some toolboxes with what these controls do. Example, I can change the control down, a control up, create new controls, insert new controls, replace name of controls and things like that. It also automatically does copies to the clipboard, a list of the reading and the information of the controls to put on the PY file. In this case, if I press this one, I say no to this question. Okay, this says yes. And if I go to Notepad, for example, just to simplify, a bunch of files here. Okay, I put it right here. So what is there? It automatically creates this code. Of course, for the passage of the code from the interface to a variable to put it on the PY file, Python file. This is a small example, okay, but for example, to show you something bigger, this one here is something that is neoprene bearing, the Python part that we created. It has around all these controls, okay. As you can see, there is a lot of information here, a lot of controls. In a few seconds, I'll show it in a whole plan. And it also on this side, it connects to, this is the order where we define the pages, the expander, radio button, everything is associated. Also important to control the level, that there is an error evaluation, because if it checks the data that is in the auxiliary sheet, that's to this one. If there is something wrong, it will indicate. For example, this line, the neoprene bearing, is something like what we have here. This one, neoprene bearing, not neoprene bearing 1, neoprene, okay. This has all these attributes and parameters, okay. If I change the different controls, image changes. If I start activating checkboxes, pages appear, okay, and the complexity of the neoprene that is being designed and drawing as a Python part starts to increment. I just put it there. For example, I've put it here. Then start doing other things. I can change it to rectangular. Of course, I can increment its dimensions. I can increment its weight. And all these are different parameters that have a meaning, function, and it has neoprene bearings fixed, guided. For example, I could put connectors. Okay, in this case, I have 4 connectors. Okay, I can go to the connectors page. Okay, can increment the number of connectors that the bearing has. Okay, also the connectors diameter, too much, of course, or the connectors height. Okay, let's put it like this. I can take the head out. That's simple stats. Okay, and it's done. Okay, there it is. Very complex one. Okay, and this is how we created, for example, this interface. So we just made this Python part. Let's click it. Okay, and it opens the interface. The code behind this interface is here, and this is the code. Okay, so explaining for the known proficient. So I have an initial part for the import of libraries. I have the Shekel plan version, create element, where it starts to create the element. I have an initial part where it creates some variables and starts some tuples. Then I have the reading of the parameters from the interface. This is the code that was automatically generated, all these parameters with an explanation. And then there is some data correction, because if some data is less or more than, then it affects automatically the other. And we are also correcting some of the information, changing the situation of some controls in the interface. But anyway, we are only using if then else, and not much more than that kind of functions. From here we are getting information from the interface, and here we are putting information on the interface. For example, we are changing the value of this control, because it has to consider some other value in other controls. So at the end, this is to avoid having a bearing that doesn't make sense. Okay. Then this is the main geometry definition, and as you see, I'm going to increase the size of the letter. This is the creation of a cube, okay, where we are putting in the main tuple what is produced by this function. And this function, in reality, if I go to its definition, okay, as you can see, it has these 3 lines of codes. We give the dimension x, y, z, and also the position of the corner of the cube, x, p, y, z, and it automatically creates the cube and avoids us repeating continuously these 3 lines of instructions. That's what I meant when I was saying that we simplify the code using broader functions that we create. Of course, in this kind, it creates a cube in the form of big rewrap. This creates a cylinder in the form of the rewrap. And also these are the parameters that are required to define a cylinder in some point of the space. Then we go to define the exteriors above and below plates. And of course, things look very similar, and the code is simpler and is cleaner than having all those instructions, because at the end, when I put this instruction, I was putting one instruction, but if I didn't use this method, I would have 3 lines of codes, and the attribution of the parameters much more simpler and condensed in this way. And if I go down the code, you can see that this is just a sequence of if then else. There is, for example, a for cycle for the interior metallic plates inside the bearing. In this case, I only have 2 plates, okay, but I can change it. It's possible to see the number of plates changing inside the bearing, like that. And this is because this cycle of 4 is running, okay. And then I go to the other elements, but in the end you can see that we are using BREP, cylinder cube BREP, and for example here you have an operation, a Boolean operation at the end, also that condenses several lines of code in a more simple way. If I go to the function, you can say that I give it object1 to unite list, ou seja, it's a list of objects, number of the object in that list to unite, a list of other objects, and the number of the object to unite, if I want to delete object 2 or not, and then it makes the Boolean operation. We have going here along the different functions that I created. I created a function to create static hardcode attributes, static attributes, dynamic list attributes. This one is to model, really create the elements with different variables. And this one also is for the properties. This is for the loft operation. To do a move rotate 3D, the BREP, you give the displacement vector and the rotation in the 3-axis in relation to a point, mirror. So every time that we should have these lines of code, we just put this line of code with this instruction, this function with these parameters. And this is already in a library of us where we list the functions that we have, what are the parameters necessary to do. For now, they are simple functions, they are not very complex, and this is how we produce that bearing. That at the end has a great flexibility and many elements incorporated in it. And the simple one is just a rectangular, a cube of neoprene bearing with no plates, nothing more inside. It's just rubber. That's it, everybody. That's our main challenge for this year, past year. Okay. As we said, our target is to simplify the creations of Python programs, Python parts, open Python for everybody. Okay, try to develop more code with less lines, with a simple code, more readable, that after 1 year, 2 years, more easily a person can come in and change the code without having a big fight over it. I hope these ideas can help you with Python parts. Maybe Oplan also can take some ideas from here. We look forward for that. Also for next year, Oplan Day. And that's it. Thank you very much. Bye-bye.